Good afternoon, everyone. This section is called 4.1, and it deals with absolute maximum, or we'll say absolute max, and minimum values. This has like a lot of terminology, a lot of definitions and everything, but it's not that difficult because it just involves the derivatives, okay? So if you see ABS, that's just shorthand notation for absolute, okay? So absolute max and min values. I know I'm just writing the same thing over again. So we're going to let C is a constant, okay? And then we have this weird little thing right here. That just means element. Let C be an element of the domain of F. When we say an element of, it just means part of, right? Like how you have chemical compounds like H2O. Hydrogen is one of the elements that's part of water, right? Because it combines with the oxygen, right, to make water. So let C be an element of the domain of F. Then F of C is an absolute max if F of C is greater than or equal to F of X for all X in the domain. So basically, if that X value that you compute, you plug into your function, if its Y value is the largest Y value within that domain, right? The absolute largest possible Y value, then we say that that particular X value, the C, winds up being the absolute max. Or it's like, think about it, absolute means the most, right? The most max within some domain interval. And then likewise, you can have the absolute min, which is the reverse. That's the second condition, right? Or second possibility. Absolute min if F of C is less than or equal to F of X for all X in the domain. So graphically, if I just draw something conceptually, like what does that look like, right? Like if we had, just like a graph like this, and you just have a curve, right? We have something like, say, I'll just call this whatever. I'll just have our curve doing this right here. This is A and this is B, right? And then we have, some nice points like that. And then we were asked, what's the absolute maximum and what's the absolute minimum between this domain interval A to B right here? Well, in this particular case right here, this would be your absolute min, sorry. Because it's the lowest Y value point, right? It's the lowest Y value that your line hits. Likewise, this right here would be your absolute max. Again, within that range between A and B, because that's the highest Y value that our particular line hits within this snapshot right here. And that's, in this case right here, this is within A, B. So remember, this is the domain that we're talking about right here. So that's that would be our absolute minimum or the lowest Y value that our line hits within this domain of A to B interval, and this would be our largest or our absolute maximum Y value within this snapshot right here, or this domain of A to B. So that's what they mean by absolute max or min. And it doesn't always have to necessarily be some point in between A and B. A could be the absolute max or absolute min, right? Like if this line was up here, it just depends on, you know, what the curve was and how they drew it. Now, these points where these maxes or mins occur at, like right here or here, for example, those are called critical numbers or critical points. A critical number or a critical point, PT just means point, of a function occurs when you have a couple possibilities. F prime of C equals 0, or F prime of C DNE does not exist. Okay, that just means undefined. And all this is happening within the domain AB. So again, when you have these humps right here, these are considered critical points. So it says a critical number or critical point of a function occurs when F prime of C equals 0. Remember, that's when the derivative equals 0. What happens graphically when the derivative equals 0? You actually get a flat line. You get basically where these humps are occurring at. Because remember, what's the derivative? It's just another way of saying slope. When the slope is 0, what happens to your curve? You're neither rising nor you're falling. It's actually flat right there. So that instant where you have the little hump occurring, that's where the slope or the derivative is equal to 0. Those will always give you critical points, okay? Now, the other condition, because the rest of the sentence says, or the derivative does not exist, undefined. What is that? What's an example of not existing? Well, it's when you have, you know, vertical asymptotes, right? Like in this case right here, an example, something like that is, well, if you have, remember, what if we had, like, say this is x equals 2, and your line has a vertical asymptote, and our curve is just doing something like this, for example, right? Just something like that. That's a possibility. If you have vertical asymptotes, are an example of something that causes a function to be undefined. So that's another instance where we would have a critical value, okay? So these are the two instances right there. And what's really important is that these values, I'll say CVs, okay? These critical values, CVs means critical values, okay? These critical values must occur at an endpoint or at a critical point. So remember, endpoints are where we define it, right? Again, like if I go back to that graph that I drew before, you know, it was doing something, I forgot what I had, or something like this, right? I had something like that. This was A and B. So the critical values can occur either at A or B, or when we say critical point, it's something in between A and B, right? So anywhere between A and B is fair game, like that. That's what we mean by these critical values must occur at the endpoints or somewhere in between. Critical points just basically lie someplace in between your domain that was specified. Now, how do we do this, right? How do we find critical values? Or how to find extreme values? So when we say extreme values, we're talking about, again, absolute max and min. Okay. Well, the first thing we want to do is find all critical points on AB or within that domain AB. So not all critical points are going to be absolute maxes or mins. The critical points, again, is just where, like in this case right here, if we were to find the critical points, we would have 3. 1, 2, 3. Why? Because this is where the derivative would be equal to 0. If we solve this particular equation, we get 3 different values right here. Now, are all 3 of these going to be absolute maxes or mins? No, you can only have, one absolute max or one absolute min in this instance, but we have 3 possibilities right here. But we still need to find all the critical points, right? Basically, where all the humps are occurring, or where you have some kind of undefined values from the derivative. Once we find all the critical points within this domain that's been specified to us, we're going to evaluate all endpoints and critical points. So when we say evaluate, it means you're going to plug in those x values or substitute them into your original function and look at the y values, okay? That's what we mean by evaluate. You're substituting these x values into f of x. And then 3, well, whichever one of these values that you substitute in gives you the highest y value, that winds up being the absolute max. So the largest y value is the absolute max. And then the smallest y value would be the absolute min. Or the absolute minimum point. So here's a typical problem right here. We want to find the absolute max and minimum values of this function within this domain interval, okay? So anytime they ask you to find the absolute max or min of anything, they're going to give you some kind of domain restriction. Okay, so that's very important right there. If they don't, then depending on what kind of degree this is, if you had x to the 100th, you would have 100 humps all over the place, and you have to sit there and do all kinds of work, and you'll be there all day trying to find out which one of these 100 humps is either the biggest or the smallest, right? Like that. So that's why they give you a snapshot of what they are looking for in particular. So how do we do that? Well, what we need to do is find first the critical points. Remember, critical points. How do we do that? We let f prime of c equal 0. So what do we need to do? We need to find the derivative of this function right here. So that's 3x squared plus 6x, plus 4x plus 1. Okay. And then we need to set this to 0. And we need to solve this for x. That, again, is going to give us the x values where the humps are occurring. Remember, wherever the humps occur, that's where the derivative is equal to 0. That's where your slope of your line would be 0. So how do we solve this, right? Got to factor it. Okay. So then you set both of these to 0, and we get x equals negative 1/3 and x equals negative 1. So we have these two values right here. Now, where do we go from here? Remember, the second step said evaluate the function f at the critical points and the endpoints. Okay? So this is our original function. So if we evaluate the function f at the critical points and endpoints, what does that mean? It means we're going to plug in all these values, meaning like I have to find f of negative 4. I need to find f of 2. I need to find f of negative 1, and then also f of negative 1/3. So where are all these numbers coming from? Where's the f of negative 4 and 2 coming from? Those are your endpoints. You must always test those when you're trying to find the absolute max or min within the region. Where is this negative 1 and this negative 1/3 coming from? It's coming from when we set the derivative, right? These are critical values right here. So these two are the critical values. These two are the endpoints. And you're always going to have two endpoints, but you can always have more than one or two or three, whatever. You can have n amount of critical values. It just depends on what happens when you set the derivative equal to 0 and how many answers you pop up with. So we're going to take all these x values and plug them into the original function, and we want to see which one's going to give us the largest y value and which one's going to give us the smallest y value. And whichever one of those are, that's the absolute max and the absolute min. So this would be negative 4 cubed plus 2 times negative 4 squared plus a negative 4 plus 1. All right, so when you're plugging this in, use your calculator. Just watch the parentheses, watch the exponents as you type all this stuff in, right? So this is negative 35. All right, so really important with the fraction one, your answer needs to end up as a fraction as well, unless it can reduce to something nice, meaning like if we had worked this out and this was like, 27 over 3 equals 9, then yeah, reduce it to that. But this right here is some crazy decimal like 0.8, blah, 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 blah. So you need to keep it in fraction form, especially on WebAssign. Now, we have all these y values, right? Which one is the largest y value? Well, the absolute max occurs when x equals 2, right? Why? Because when x is equal to 2, y was 19. This is the largest y value. So that is the absolute max. If on WebAssign it asks for a point, then you would say 2 comma 19. This is where the absolute max is happening at, right? Because when x equals 2, y equals 19. Where does your absolute min occur, or the lowest y value? Well, which one is the smallest? It's right here, negative 35, when x equals negative 4. Why? Because when x equals negative 4, y is equal to negative 35 right here. That's the lowest y value. Now, in this case right here, it was the endpoints, right? So maybe you were thinking, I didn't even have to take the derivative. Why did I even waste my time with finding the derivative and then plugging those critical values into the function to see if they were either the highest or lowest y value? Well, it's because it's not always going to be the endpoints that are the absolute maxes or mins, okay? That can change anytime. It just depends on what your initial function was. All right, let's try another. Like if we have f of x equals x to the fourth minus 4x squared plus 2. And then we have this interval negative 3 comma 4. So again, what do you need to do? We're going to have to sit here and find the derivative, right? Finding the derivative and setting it to 0 is going to give us critical values, right? Critical values, again, is where the derivative is equal to 0 or the derivative gives you some kind of undefined value, all right? So what is the derivative in this instance? It's 4x cubed minus, and then we get 8x, right? Now, we have to set this to 0. How do we go about solving it? Well, it doesn't have 3 terms like the last one, right? But as I mentioned before, if you have no idea where to start with simplifying some kind of problem or equation or an expression, ask yourself, is there a GCF, right? There is. Look, they both have a 4x in common. If you take that out, you're left with x squared minus 2, just like that. And from here, this is equal to 0. Now, what do we do from here? We set both of these to 0. These I'm setting to 0 because one of them's a little more tricky to solve, right? Like this is x equals 0 right here. That's fine. That's not an issue. With this one, though, how do you solve it? Well, you'd have to, add the 2 to the other side and get x squared equals 2. But then you have to take the square root of both sides. And in doing so, you're going to get x equals, and then you're going to have plus or minus the square root of 2. Remember, whenever you use that square root property, or you take the square root of both sides, the side with the constant, you're going to have plus or minus. You're going to have 2 answers, right? You have to. That makes sense because if I take root 2 and square it, I get 2. Or if I take negative root 2 and square it, I also wind up with positive 2. That's really important, right? You have to have 2 answers from this. Even from here, remember the degree of your equation tells you how many solutions you should have. So if we have x cubed, 3 is the highest power, we better get 3 answers in the end. Like if we solve this one for x specifically, we would get 4 solutions because your degree or highest exponent is 4. But for this one right here, 3, which is what we got. 1 and then 2, 3 right here. Now we have all these values, right? We need to plug them into our original equation and see which one's going to give us the largest y value and the smallest y value. So we need to find, remember, we need to evaluate the endpoints and the critical values right here. So we need f of negative 3, f of 4, f of 0, and then f of root 2, and f of negative root 2. So remember, whenever you plug in these values, when you're trying to find the absolute max and min, you always plug them back into the original function. Don't plug them back into the derivative, okay? Everything goes back into the original function. All right, so with these, when you evaluate, it looks a little tricky, but it's not too bad, right? If I take root 2 and you raise it to the 4th power, right, you can plug that straight into your calculator. You will get something nice, right? This is basically 4 right here. This is 4, and then minus. This is 4 times 2, which is 8 plus 2, right? Square root of 2 squared 2 times 4 is 8. Same thing's happening right here, right? This is a negative raised to an even power, still going to be positive. This is 4 minus 8 again, plus 2, and that gives you negative 2. Now, with this case right here, remember we're looking for the largest y value, right? If we want to find the absolute max. So right here, this is the largest one, largest y value. So f of -3 is the absolute max. And again, this is happening at -3 comma 47. Why? Because that's the largest y value. Now, as far as the min, well, there's two of them that have the same exact min value, right? Both of these spat out -2s right here. Can you have more than one absolute max and more than one absolute min? Yeah, you can have different points share that either highest y value or lowest y value. So in this case right here, both, I'll put it right here, both x equals √2 and x equals -√2 are the absolute mins. So you would say, oh, at √2 comma -2 and -√2 comma -2. So on WebAssign, pay attention to how it asks you to input these answers, okay? If it wants points, this would be it right here. If it's asking for what's the x value, where's the x value that the absolute max occurs at, you just put -3. If it asks you where are the x values where the absolute min occurs, you would put √2 and -√2. Don't put x equals, okay, because most likely they're probably going to have the x equals in the answer box already. So don't double up and put another x equals. Just watch how they put those values in there. Watch how they specifically want the answer, okay? So that is it for part 1. Part 2 will be posted in a little bit or shortly.